Welcome to Study Loop.
Okay, we have the following molecule. It's a little large, so it'll take me a moment to draw it out. Okay, and each of these double bonds has been labeled from left to right: A, B, and C. And what we've been asked to do is assign the correct stereochemistry to each double bond. And so the way you want to do that is fill in any of the implied hydrogens. Recall that every carbon with a double bond should have 3 substituents, so if it's only got 2, just add hydrogens where none are pictured. Okay, then let's take a look at our first double bond A. Split it in half, right, across the double bond this way. So this is one side and this is the other side, right? So you're looking at the individual carbons, and you look at the carbon and you say, of the 2 substituents on the carbon, here and here, which has higher priority? Well, in this case, they're both methyls, so neither has higher priority. And if you run into a situation where one side of your double bond has 2 substituents of the same priority, then it cannot have stereochemistry. So A is none. Okay, let's look at B now. Okay, so we're going to split it in half and look at it carbon by carbon. Okay, so let's start with the carbon on the left, and we say, what's higher priority, this hydrogen or this carbon? And we know that carbon is always higher priority than hydrogen, right? Because it is a higher atomic number. So we're going to label the carbon 1 and the hydrogen 2. Now we'll look at this side of the double bond. I'll do this in a different color. So now we're looking at this carbon. We're saying now we're comparing a carbon to another carbon. And since those are tied, we then look at what each of them are connected to. This carbon is attached to 3 hydrogens, whereas this carbon is attached to 2 hydrogens and a carbon. And at this point, we compare the highest priority substituent attached to the 2 tying carbons. So in this case, our highest priority substituent attached to the carbon that's tied is a carbon. In fact, we can write out all the substituents from highest to lowest priority. So over here we have carbon, hydrogen, hydrogen. And here we just have hydrogen, hydrogen, hydrogen. And I like to do it from highest to lowest. And so we compare the highest from each group. That would be carbon versus hydrogen. And since carbon wins, we're done. And we know that this particular carbon, which was attached to carbon, hydrogen, hydrogen, is higher priority than this carbon, which is just attached to 3 hydrogens. Right, so as soon as we catch a difference and one of them breaks the tie, then that's the winner. So in this case, we now have, in terms of ranking, that this is the higher priority than this carbon. And now your final task is to connect with a line the highest priority substituent on each side to the other. And if you cross over the double bond when you do this, then we consider this to be trans, or in terms of E and Z, this is E for entgegen, German for opposite, because the groups are on opposite sides of the double bond. So B is E stereochemistry. And now let's look at C. Okay, 1 carbon at a time. Okay, what's the highest priority substituent on this side? We have a hydrogen, and then we have a carbon. Carbon is going to win. Hydrogen, second place. And now we look at this carbon. We've got oxygen versus, there's a carbon in there, so oxygen versus carbon. Oxygen has a higher atomic number, so oxygen wins. This is number 1, and this is number 2. And now we connect 1 to 1. And look at that, we crossed over the double bond, meaning the highest priority substituents are on opposite sides of the double bond. And so C is E.